We're going to talk about section 9.2 in our book, Identities, Expressions, and Equations. Try to see the difference between these. We've talked a little bit. An identity is an equation that is true for all values of the variable. Our favorite identity, of course, in trig is sine squared plus cosine squared equals 1. But we have some others. Sine negative x equals negative sine x because sine is an odd function. Cosine of pi over 2 minus x equals sine of x. That's one of our cofunction identities. Because sine and cosine are cofunctions, then the sine of an angle is the same as its cofunction of its complement. And there's our favorite identity, sine squared plus cosine squared equals 1. When we say verify the identity, we are actually asking for a proof. So if we are trying to verify that tangent x times cosine x equals sine x, we can change our tangent x into sines and cosines and see that on that left side we can cancel the cosines, and that in fact that is a true statement all the time. So sine x is going to be equal to sine x always, and we have verified that identity. An expression is something with no equal sign. So the directions typically for an expression are going to be to simplify it. So if we recognize that that's an alpha there, that thing that looks kind of like a fish, another Greek letter to name an angle. So the sine of alpha over 2 over the cosine of alpha over 2 is the tangent of alpha over 2. And that will be our simplification. Similarly, we can see here that the sine of 1 minus 1 over z over the cosine of 1 minus 1 over z is also going to be a tangent, and the extra 2 and 3 will just be that number 2/3, or that fraction 2/3, times the tangent of 1 minus 1 over z, and we have simplified that expression. This one's a little more typical of identities. We're trying to simplify this, so we're going to think in order to add fractions, we need a common denominator. So the fraction on the left, we're going to multiply top and bottom by 1 plus sine x over 1 plus sine x. That's just multiplying by 1. And the second one, we'll multiply top and bottom by 1 minus sine x over 1 minus sine x. So in the first equation, 1 times 1 plus sine x is 1 plus sine x, and then we'll get plus a 1 minus sine x out of the second one. Both of those equations, when you multiply 1 plus sine x times 1 minus sine x, is going to give us the difference of two squares, 1 minus sine squared x. So we can see that in the numerator, the sine x and negative sine x will cancel. In the denominator, you may recognize that as our old friend cosine squared x, which is going to then make this be 2 over cosine squared x. Then we can recognize that since the 1 over cosine squared is also known as secant squared x. And that's what we're trying to get with that one. Okay? Now, an equation has an equal sign and may be true for some values of the variable. So we say solve the equation. We've been doing this for a while. So we could say factor that cosine x out, the greatest common factor. Do not divide by cosine x, because then you're assuming it's not 0. But if cosine x is equal to 0, those are going to provide solutions. And we'll set the second equation or factor equal to 0 as well. And so we are going to be asking ourselves for what values of x is cosine 0. and that's going to be pi over 2 and 3 pi over 2. And where is cosine a half? In quadrant 1, that will be at pi over 3, and cosine's also positive in quadrant 4, so that will be at 5 pi over 3. Those are all solutions between 0 and 2 pi. Okay. So the following problems, now we'll use formulas that come from our formula sheet, which will be on Canvas, or I'll hand out to you if you're in class. I can give you a hard copy. We'll need to use that formula sheet on a bunch of these homeworks and also on the test, so make sure you keep it with you all the time. So first we're going to solve over the interval from 0 to 2 pi. So we have here, the issue is we have this 2x, this double angle, and this is a different one. So we can't really go anywhere when those are different angles. So we're going to look at, we're looking at that first double angle formula. Sine 2x is 2 sine x cosine x. So we will replace the sine 2x by 2 sine x cosine x. Now everything's got the same angle, so we can proceed as we have before. Looks like there's a greatest common factor of 2 cosine x. That will leave us with a 1 plus sine x. So we can say either 2 cosine x is 0 or 1 plus sine x is 0. Dividing by 2 means we want to know where is cosine 0. And that's going to be at pi over 2 and 3 pi over 2. And subtracting the 1 means where is sine x equal to negative 1. And that's going to also be at 3 pi over 2, which we've already got. So those will be our solutions. Now, on the green, we're kind of going the other way. If we see, on this one, I wrote that down wrong. Let me fix that. And it's supposed to be a 2x right there. So now, like we saw before, we can replace our 2 sine x by, we have the 2 already outside, and then the sine 2x is 2 sine x cosine x. We have that other sine x, and then finally equals our cosine x. So it looks like we can call that 4 sine squared x cosine x. Let's subtract that cosine x to make it equal to 0. And now we can factor out our cosine x, leaving 4 sine squared x minus 1 equals 0. So we can say cosine x is 0. Then we can take our 4 sine squared x minus 1 equals 0. That's going to be 4 sine squared x equals 1. Sine squared x equals 1/4. Square root both sides. And remember, we want all possible solutions. So that's going to be the square root of 1 is 1. And the square root of 4 is 2. I'm going to slide this up. So from the cosine x equals 0, that is going to give us pi over 2 and 3 pi over 2. Now sine x is a half at pi over 6. It's going to be a positive or a negative a half in each of the 4 quadrants with a reference angle of pi over 6. So that'll be 5 pi over 6 in quadrant 2, 7 pi over 6 in quadrant 3, and 11 pi over 6 in quadrant 4. So those are all solutions. Now the next one, we're going to again replace that sine x by 2 sine x cosine x. We still have the plus cosine x equals 0. We'll factor out that cosine x, leaving 2 sine x plus 1. So cosine x can be 0 or 2 sine x plus 1 is 0. And so either if cosine x, well, yeah, if cosine x is 0, we're going to get pi over 2 and 3 pi over 2. And if 2 sine x plus 1 is 0, 2 sine x is negative 1. So sine x is negative a half. So that's going to give us reference angle in quadrant 1. Sine is 1/2 at pi over 6. Sine is negative in quadrants 3 and 4. So that'll be 7 pi over 6 and 11 pi over 6. And those are all answers. All right, different kind of problem. Now we're going to try to evaluate. First, let's do sine 2 theta, given that cosine theta is 5/13 and we're the 3 pi over 2 to 2 pi means we're going to be in quadrant 4. So sine 2 theta, remember, is according to our formula 2 sine theta cosine theta. So we need to know both of those. We know the cosine of theta. We need to know what the sine of theta is. We were told our reference angle is going to be in quadrant 4. The cosine we were told is 5/13, which is adjacent over opposite. We can do a Pythagorean theorem or recognize this is a Pythagorean triple. So, and because we're in quadrant 4, that'll have to be a negative 12. So that means we're going to get, I guess I'll stick with the green. So that's going to be 2 sine theta times sine theta, which is a negative 12/13, and cosine theta, which is 5/13. And so that is going to be 2 times 5 is 10, times 12 is a negative 120, and 13 squared is 169. Now, tangent of 2 theta, let's go back and find our formula. Let's see, tangent 2 theta is 2 tangent over 1 minus tangent squared. 2 tangent theta over 1 minus tangent squared theta. So for us, our tangent theta from SOHCAHTOA is going to be opposite over adjacent, and that's going to be a 1 minus tangent theta was our negative 12/5 squared. So that's going to be a negative 12/5. We've got a 1 minus, that's going to be 144 over 25. So the 1 we're going to make into 25/25. So we have a common denominator. So we're going to get our, let's see, we still got our negative 12/5 on top. Let's see, 25 minus 144 is going to be, I think, 119. So it's going to be a negative 119 over 25. So I guess we can cancel the negatives. They'll drop out. We're going to have that 12/5 times, that'll be 25 over 119. And so we can cancel the 5 with the 25. And then 12 times 5 is 60. And 119 is our denominator. There it is. Let's try another one of these. This time we're going to be, according to our information, pi over 2 to pi is going to be in quadrant 2. We want our alpha, our angle alpha, to have a cosine that's a negative 2/7. So a little Pythagorean theorem, 49 minus 4 is 45, and the square root of 45, we're probably going to want to call 3 square root of 5. Let's see, cosine 2 theta. We need to go find an identity. hang on, I'm going to scroll back up. And cosine 2 theta is cosine squared minus sine squared. So we're going to say cosine squared minus sine squared theta. So according to our triangle, cosine is adjacent over hypotenuse. It's going to be a negative 2/7 squared minus the sine. I guess I'm going to leave it as square root of 45 because we're going to get rid of it in a moment here when we square it. So square root of 45 over 7 squared. So that's going to be a 4/49 minus 45/49. So I guess that's going to be a negative 41/49 for our cosine 2 theta. Tangent 2 theta, let me change colors for this one. Let's go with, maybe we'll go red. So tangent 2 theta, I think we said up here was 2 tangent theta over 1 minus tangent squared theta. So that's going to be 2 times tangent theta is opposite over adjacent. So I'm going to call that 3 square root of 5 over negative 2 all over 1 minus, since I'm going to square that, I'm going to go back to calling it square root of 45 over, it's the opposite over adjacent, to negative 2 squared. So that's going to be, I guess we can cancel these 2's. So that's going to be a negative 3 square root of 5 on top. And we're going to get 1 minus, that's going to be 45/4 for the tangent squared. The 1 we're going to make into 4/4. So that's going to be a negative 3 square root of 5 all over, I think that's a negative 41/4. So that's going to be a negative, I guess we can cancel the negatives, right? So those will drop out. And we're going to get a 3 square root of 5. Going to multiply by the reciprocal. So that's going to be a 12 square root of 5 all over 41. Okie doke. One more of these. So this time we're told that we're back to quadrant 4. So 3 pi over 2 to 2 pi is down here. And we're going to say that the cotangent is negative 6. Now tangent is opposite over adjacent, so this will be adjacent over opposite. And if we're in quadrant 4, that means that the opposite side must be the negative side. Using some Pythagorean theorem, these are not going to be pretty. That's 36 plus 1 is 37, so yuck, that's going to be the square root of 37. So our sine of 2 theta, this is the only one I can remember, is going to be 2 sine theta cosine theta. And for us, that means we're going to get sine theta, which is opposite over hypotenuse, which we're going to need to rationalize, but I think it's going to work itself out because cosine is going to be adjacent over the hypotenuse. So it's going to rationalize itself for us there. So that's going to be a negative 12 over 37. So there is our sine. And cosine, I'm going to change colors again. I think we haven't done yellow in a while. So cosine 2 theta is cosine squared theta minus sine squared theta. So cosine, we're going to square it so then we don't have to rationalize our sine and cosine. Cosine we said was adjacent over the hypotenuse squared minus the opposite over the hypotenuse squared. So that's going to be 36 37ths minus 1 37th is going to be 35 37ths. All right, very good. I think that's all I got. Let me just make sure. Yep. Okie doke.